Hello guys, today I'm going to show you this projectile motion problem. It's basically you're kicking a football, all right? It's a football field, and here's you, all right? You're wearing a hat, all right? And here's the football that you're going to kick, all right? So when you kick it, basically you're giving it an initial velocity, which will be in this direction, okay? Velocity vector that will make an angle with the horizontal theta. This is the initial velocity, right? So let's call this V naught, and this theta naught. All right, so once it leaves your foot, the only force acting on it is gravity, right? Gravity is downward. By gravity, I mean the gravitational acceleration. So it's a negative number. It's pointing downward. That number is called G. If you like to use unit vectors, negative G times J hat. All right, so G is accepted as 9.8, maybe 81 meters per second square. All right, well, we're interested in how far the ball is going to fly, okay? Where is it going to land? So it's going to be a parabolic path, like this, okay? So it's going to land a distance, let's say R, away from where you kick it. Okay, R stands for range, obviously. And, well, somewhere in the middle, ignoring air, friction, and all, we're going to reach a maximum height, right? So maximum height, let's call it H. Okay, so here's our problem. Can we find H and R in terms of the initial conditions, basically V naught, all right? So given V naught, how do you find these two? And then maybe how do you maximize the range? So once you find a formula for the range in terms of V naught as in magnitude and direction, so including theta naught and G. So in terms of V naught, theta naught, and G, can we find the parameters that will give us the maximum R? All right. Now, if you think about it, when you kick a football, you have a certain power, right? Let's say you're using all of your power, your maximum kicking power. That corresponds to a maximum V naught, right, in terms of magnitude. But what you can still change is the angle you kick it, right? The angle. So by changing the angle, can you maximize R? So on the side here, let me draw you a couple of options. For instance, kick it like this, or like that. Obviously, the initial angle right there will determine how far it'll land, okay? So, what's the optimum angle? All right, what is the angle that will maximize R? That's part of our problem. So, this is the part one of this video. In part two, I'm going to try the same problem, meaning maximum range problem, but I'm going to consider not a football field, but maybe something like this. You're standing at the edge of a cliff, and then you kick it here, and then it's going to fly like this. Now, what is the relation between this distance, call it D, and the initial parameters, okay? But that's part B. B of this series. This is a little bit more, it's kind of a lengthy calculation, and not all textbooks show this solution, but this one here, let's call this part A. You can find the solution in any elementary physics problem or introductory physics problem, whether it's a college physics or university physics, it's in there, okay? The first problem is there, but the second problem, I can show you where you can find the problem, but I'm going to show you the solution, all right? Okay, so let me stop right now the recording and then see how it turns out. Okay. All right. By the way, in the background you're probably hearing some good music. That's Jimmy Bruno.